Today I'm going to look at how we can think about graph transformations and how we can use GeoGebra to really help us gain a deeper understanding of what they actually do and what the usefulness of them are. So the first thing I'm going to do is I'm going to invite you all to go onto geogebra.org and go onto classic and graphing, and you should get a screen similar to this. And then I'd like you to just put in a function. It doesn't have to be the same function as me, but I'm just going to use f of x equals, and then I'm going to do x plus 1, x minus 2, and I'm going to square this function, and then I'm going to again multiply this by x. Once I've got this function, I'll just look at some of the properties, and we might know how to work these out. However, using GeoGebra, if I just click the intersection tool, I can work out what these roots are, and they should be fairly obvious because I have already put in my equation, so I could work out my roots from there: -1, +2, and 0. So I've got my roots. The only other thing I maybe want to think about when I'm looking at a transformation is about these points here. Now, they're what we call the turning points, so we've got a maximum and a minimum, and you'll notice there's one at our root D as well, because x minus 2 squared is going to be a repeated root. And to think about them, you just need to look at the extremum, because that's what they call in GeoGebra, and it's of our f of x. So when I put my extremes of f, we have this value 2, 0, because we know what that is. And then we also have these other two values at around -0.6, -1.6, and +0.8, +2. So if I want to think about what would happen if I multiply this function, I could say that y equals, and I'm going to use k lots of f of x. And when I pop that, sorry, I need to multiply, which is here. When I plot that, I get this function which has been plotted on top in purple. However, I can also introduce a slider, and I'd encourage you to think about what would happen as I increase the value of k. As k increases, we can see that my graph starts to be stretched out, but what do we notice about the turning points and the intersection points? It should be fairly obvious that the roots wouldn't change, because we are just multiplying by a constant at the front, so it wouldn't be changing our roots. And the turning points will be in the same x coordinate, however their y coordinate will be varied depending on what this k is. Okay. The next thing I'd encourage us to look at is what would happen if I had y equals, let's say, f of x, and I want to add on k. And I can hide my previous graph, and again I can see what happens as I add and subtract k, and we should know that this is a vertical translation parallel to the y-axis, and it's just moving my graph up and down. Again, if I click on this, it's going to hide that graph. Using k again, I want to think about what would happen if I had y equals f of x plus k. So this is where it's inside. And again, if I move k towards a positive direction, I want you to think carefully about what way the graph translates. And likewise, if I move it in a negative direction, again, I'd want you to think carefully about which way the graph translates. And the final feature that I'd like you to explore is, what if I tried to plot the graph of y equals f of kx? And again, as k is 0, it's a straight line, but as I increase the value of k, we can see that it seems to be shrinking in. And as I decrease it, it starts to be stretching out. I'd encourage you to think about what happens when it's negative and positive, and why does it approach the line x equals 0 when my k is 0. So thank you for watching. I'd appreciate any notes that you've taken to be brought into the next session, and if you have any further questions or queries about how we do anything, or even you have some feedback on how you think this went, it will be greatly appreciated.